Okay, let's start talking about transformations of exponential functions. Remember this formula that we kind of figured out in the last podcast? Well, let's put it to use. Remembering a couple of things here, though. Remember that this C stands for vertical compression or expansion. Okay, that's vertical. And inside here is that horizontal one, right? And if you remember correctly, the horizontal one is always flipped. So the horizontal compression expansion is going to be 1 over d, all right? And then you've got these other wonderful things. This is going to move vertically, right? So the verticals all go together, and this guy is going to move horizontally. So that goes together. And you know, this is still all the way back to that nice little math 20-11 that you did with the parabolas. Exactly the same idea. The only nice thing here that we've done in Math 30 is we've given you this wonderful little formula that takes all of the things, there's the D, there's the C, and puts it into this formula so you can actually start generating points. So it's obviously, it's even easier than the Math 20. Let me show you how this works. I got a beautiful example for you right here. Take a look at this example. Notice that we have already done the transformation on this. So what I want you to think about is I want you to go back to what is the root of this particular question. Well, I just underlined it. The root of the particular question is this: y equals 2 to the power of x. That's what it looks like. Now, take a look and see what you've done to this thing. What you've done is this. You've got a horizontal here of a stretch or compression, and look how this is in line with this. So obviously, that is your vertical up-down movement, okay? That's your vertical up-down movement. So let's go back to this equation and figure out what that means. This horizontal here must mean this D value. Okay, so that's your D value. The vertical must be this guy right here, the minus K value. Okay? So the first thing I would do is I would use this formula and generate a new formula. So here's what I would do. Watch this. Put down the original. Let's figure out the original table of values. This is y equals 2 to the power of x. So we're going to figure out the original x, y values all the way below us here. Then do this. We want the y equals 2, the 2 to the 2x plus 1. So let's figure out using this guy now, okay? So your x over d, your d then is, right there, is 2. Is there an h here? No, there's not. Okay. Plus 1. So wait a second. Is there a c? Well, if there was a c, it would appear right here somewhere, and there's no c. So let's just assume it to be 1. So your y values are just y plus k. And your k is plus 1. So what you've just done, plus 1. What you've just done is you've generated a formula for it. You're taking every one of the x's and dividing it by 2, every one of the y's, and you're adding 1. Now wait a second. Where do you get these values right here from? Well, you know what? From your calculator. Boom. All I did here is, if you look in my y equals 2, is I put 2 to the power of x. I've hit the original graph. There's my original graph. And now all we want is a table of values. And there's my table of values right here. I'm going to pick really, really easy, nice numbers to work with. I'm going to pick this one right here. 0, 1, 1, 2, 2, 4, 3, 8. Those are the 4 values I'm going to work with, and then I'm going to translate them. So check this out. Here comes 0, 1, 0, comma 1. There's my first value, my original. Let's go back to here. Next one is 1, 2, 2, 4. 1, 2, 2, 4. And finally, can't remember the last one. There it is, 3, comma 8. And now, using this formula that we just derived here, based on the original equation right here, let me erase this so we can see it again. There it is, okay? Which tells me to take my horizontal right here, okay? Oops. My horizontal here, divide it by 2, which is what I did here, okay? Add 1 to my vertical, which I did here, okay? So here we go. Let's take our original, which was 0, put it in there. 0 over 2 is that one, right? Y plus 1, that would be 1 plus 1, giving me my new point, which of course is 0, comma 2. Perfect. Let's go to my next one, which is 1 over 2, right? My y would be, of course, 2 plus 1, which would end up giving me 1/2, 3. Perfect. Take my next point here, okay, which is 2 over 4. So there's 2 over, oh, sorry. Yeah, 2 over 2 plus 4 plus 1, okay, which would give me 1 comma 5. And my last point, which would be 3 over 2. And then there's my 8, right? 8 plus 1, which gives me 3 over 2 and comma 9. And now I could just go to my graph and just plot these points and I'll get my new transformation. So let's go plot the original in red. 0, 1, there's 0, 1, 1, 2, there's my original, 2, 4, there's my original, and 3, 4, 5, 6, 7, 8. My original graph kind of looks like this, going out there like this. My new transformed graph, which we'll put in green, is starting here, 0, 2, 0, 2, there it is right there. Next one, 1/2, 3, which would be there, okay? 1, 5, 1, 3, 4, 5 here, okay? And 3/2, 9. 3/2 is 1.5 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like this. My new graph is going to look like that. And you can actually see that, yes, it is moved up 1 from here to here. See how it's moved up 1? And everything is shifted and compressed back. So we've got our horizontal compression of 1/2 and our shift upwards of 1. And I'll do another question like this in another podcast.